7/9 plus 1/15. Okay? So, here's the thing. I need a number that all these numbers go into. Uh-oh. Wait a minute. We've been doing 2 numbers. Now they throw us 3 numbers. I don't know. Now, it would be really nice if 9 went into 15, huh? Or if 9 and 6 went into 9. But they don't. But remember, I bet we can solve this problem by using our manipulative tool. And our manipulative tool is prime factorization. We take our 3 numbers, 6, 9, and 15. Why do we take those numbers?
Because they're all odd.
No. What is common about those numbers when you look at this problem? Remember, we're adding all these up. What are they? The bottom number, the bottom number. They're all the denominator. You can't add fractions without the denominator being the same. So we need to find a way to make these denominators the same. So we manipulate the denominators. And by manipulating the denominators, the numerators will get manipulated also. So, what number goes into 6, 9, and 15?
3.
3. How many times? Twice, 3 times, and 5 times. Okay? Now in this case, I'm hoping, I don't know, but I'm hoping this is the lowest common multiple. It would make sense. That's the way it worked before, right? Let's see if it works again. So what is 3 times 2 times 3 times 5? And it is, well, 6 times 3 times 5, so it's 18 times 5. Wow, there's that number again. And then 18 times 5 is 50 plus 40, so we got 90. For some reason, 90's been coming up a lot today, but it's telling us 90. Now, all these numbers go into 90. Well, is there a smaller number? Well, I know that if that's true, I know that all those numbers do go into 90 because 3 times 6 times this is 90, right? Oh, what did I just do? I said 6 times 15 is 90. 6 times 15 is 90. Oh. So here I've got 90 and I've got 5 times 15, which is 50 plus 25, or 75. Right? Okay. I also know that 3 times 3, right, times what's ever left, in this case 10. 10 times 9 is 90, right? That made sense, right? So these 2 times these 2, so times 10 is 90, so that's 70 over 90. Okay? And then, let's see, better use blue. So then I know that 3 times 5 is 15, right? So these two times these two, which is 15 times 6. Oh, 15 times 6 is 90. So remember, I just do the same thing to the top as I did to the bottom. So 6 times 1 is 6, and 6 times 15 is 90. And look, they all have the same denominator. Again, very complex, but also very simplistic. You find your LCM. You find your GCF. Okay? By finding your GCF, you find your LCM. That LCM is your LCD. That tells you what all the numbers are that go, the lowest number that all these numbers go into. Okay? Then I'm able to manipulate each one of these numbers, 6, by multiplying it by the other numbers that are left in the LCM. Think about it. My LCM is 90. Let's erase this part. My LCM is 90. It's just this number times this number times this number times this number. And what I said was 6 times 15 is 90. And then I said, well, wait a minute. I said that these two numbers, or 3 times 3 times 2 times 5, which is 9 times 10 is 90. That's how I got this one. And then I said, well, wait a minute. It's always these numbers, right? Well, 3 times 5, okay, so it's 3 times 2 is 6, 3 times 3 is 9, and then 3 times 5, and then what numbers are left? Which is 2 and 3. So boom, these two are left, 2 and 3. So now I have 15 times 6 is 90. So again, 15 times 6, 15 times 6, 9 times 10, 9 times 10, and 6 times 15, 6 times 15. A true, organized method to use every time. Works every time.